All right, Mr. G Math coming at you live, 7202. Now I have my peeps here, so I have a better energy when you're here than when I do it by myself. So, lesson 7.1, beginning of it. This lesson's all on, this whole unit's on exponentials, right, and how it connects to calculus. So 7.1 is a review on exponentials. Can you graph it? Can you solve equations? Do you understand basic exponential rules? That's the algebra part. Guess what trips you up more, the algebra or the calculus? Always, right? It's the algebra, right? We have to keep up. That makes the calculus easier. So let's follow the lesson for today. Today we're connecting it to calculus. So use your calculator to graph y equals e to the x. Go for it. Use your calculator to graph y equals e to the x. Do you know where the E button is? E is on the left, right? It's right there. Usually E, you have to press like a second button to get it, but not here, right? It's right there. Just the A button. Here. E, right there, underneath the little roof. The exponent button, right? So, can you press that? And then in the exponent, just put down X, press enter. Does that look like an exponential? Yeah. Good, because it goes forever to the right, but yet it has an asymptote on the left where the limit on the left is 0, but on the right is infinity. E is just a number, correct? Not a letter. And it's irrational like pi, it's about 2.7. All right, what would happen on the same graph if you graphed the derivative? Do you know how to graph a derivative with this calculator? Yeah. Here we go. So press the tab button. If you press the tab button, it opens up the ability to do another equation on the same graph. I think the quickest way to get to derivative is using this button that's beside the 9. Do you see that one beside the 9? We used it for integration, but all the fancy calculus stuff is there, right? So press that button. Can you highlight, see what I highlighted over? Can you highlight over the derivative one, not the integration one? And then press enter. I'll give you a moment. Yeah, press enter. Did you do it? It's not going to blow up or nothing. So press enter. And then did you get what I got? All right, what should I put underneath on the bottom of the fraction? That's right. So this is like dy by dx, but our y is going to be what? What is y equal in this case? Is e to the x. So in other words, that's the derivative of e to the x, and we're going to graph it on the same graph, and you're going to tell me what happened. What? So tell me what happened. It's exactly the... Now you can understand why it's so beautiful. You know why? What's the derivative of e to the x? E to the x. When you integrate e to the x, what is it? Plus candy. Thank you. Isn't that beautiful? Of all the different rules that are in your head? What's the derivative of e to the x? Some of you are going to forget this, right, on your quiz? Ha! When you integrate e to the x, it's e to the x plus c. But can you see how it's the simplest of all calculus rules? Yeah. Talking to me? Talking to me? Yeah. Yeah, we're on the board. Choo-choo. Here we go. So, let's look in the box. Hey, the derivative of e to the x is? Good. Now, what would change that? If in the exponent, you took the derivative of what's ever in the exponent, and it's not 1. Like if it's just x, the derivative of x is 1, and you don't go times 1 as a hook at the end, right? But if it was something else algebraic that you could take the derivative of, that would create a hook at the end. Now, it's a little more challenging, just a little, if the base is not e. E is the best base in calculus. Whenever we have a choice to change the base, and we will, to a base, you always pick e. Can you see why? Good. Now, if the base is another number other than e, it's still that. So if it was 2 to the x, it would be 2 to the x, but it needs a natural log hook to it. So in other words, it's whatever the base is to the x times ln whatever that base is. That's the formula. So if it was 2 to the x, it would be 2 to the x ln 2. If it was 3 to the x, it would be 3 to the x ln 3, whatever that base is, right? Now, could there also be a hook in the exponent with that formula? Right, whatever's in that? Yes. So we're going to practice that right now. And you can see the general formula on the right is with hooks that could be in the exponent. But we learn best by practicing. Number 1, can you differentiate? What does that mean? Good. Can you write dy by dx? Can you go y prime? Why not? What's the derivative of e to the x squared minus 3x? That'd be e to the x squared minus 3x. When you take the derivative of the exponent, what do you get? 2x minus 3. Done. Me too. How about the next one? Can you take the derivative of g at t? So, this one might be helpful to do a little algebra before we do the... So what's a better way to write negative 3 over t? Negative 3 to the t. They're equivalent, right? If it's a fraction, you can write it as an exponent, right? If it had a radical sign, you can write it as an exponent. All things in calculus are way better with an exponent rather than a fraction or a radical sign. All right, now we can do it. So, and we can leave it in that form. So it's e to the negative 3, t to the negative 1 times, what's the derivative of the exponent?
Negative 3, t to the negative 2. It's positive 3. Yeah, just 6.
I'm as confused as you are by hearing your answers. So let's pretend that we're going negative 1 times negative 3, which is positive 3. Let's know we're doing the derivative. That means we're subtracting 1 to the exponent. So that means it's t to the negative 2. So look at it and go, oh, yeah. What was I thinking, right? So it's positive 3 t to the negative 2. All right, next one. What are we going to do first? Yeah, right? All things, right? Whether it's a fraction or radical sign, is always easier to change it first to an exponent. What would that be? Now take the derivative. What's the derivative? That would be 3 to what exponent? It needs a ln what? That's the formula. Remember we talked about that formula? So what's the formula to take the derivative when it's the base is not e? We need to include ln of the base. That's it. It's the same formula, but what does it need still? Ln of whatever the base is. So do you see ln 3? I needed that. Now we still have a hook from the exponent. What's the derivative of the exponent? That'd be 1/2 v to the... Done. 1/2 v to the negative 1/2, right? What happened? Was that too much? Or are you reading the next question? Okay. Are we okay with the basic rules, formulas? And you know that I'm just introducing it to you. As you practice, I hope you find it easy. And if you don't, on Friday, we talk about it, okay? 4. I don't know what that means. The relative extrema. What does that mean? It's like a crazy uncle. No. What is that? And relative means it's not the endpoints, but it's in between. It has to change, right? From increasing to decreasing or decreasing to increasing. I forgot. So I have a sense that this means, because we're doing derivatives in this one, right? This lesson, it probably means the derivative. How do I take the derivative of f at x? So let's say that that's the product rule. What would be the first term? Negative x. What's the second term? And they're being multiplied, right? What's the product rule? Hey, let's just say, hey, you guys are going way too fast. My brain is slower than that. First term is what? Times the what? Let's do it. What's the derivative of the second? E to the negative 2x squared times negative 4x, beautiful, plus, so you just told me the first times the derivative of the second, keep going, or the second times the derivative of the first, which would be, and then what do? There are two things we look for. We're looking for the critical numbers, right? How do I find the critical numbers? And is there something that would make it undefined, right? Now, for an exponential, the domain is all real numbers. The other thing's a polynomial, all real numbers. There's nothing that's going to make this undefined. So, when you make it equal to 0, how do you solve it? All right. One of the skills that you have in algebra is to solve something by factoring. What do you notice that is the same with both terms? E to the negative. Remember we talked about the algebra being more challenging than the calculus, right? So we're trying to build up both. If you factor it out, what are you left with? Now I'm going to combine it together. Negative x and negative 4x is positive 4x squared. So if you factor out an e to the negative 2x squared, what you're left with is 4x squared. What are you left with when you factor it out on the second one? Just negative 1. And again, we're making it equal to 0. I have like cute little ends there, 0, 0. So once it's factored, how do you solve an equation? Once it's factored, how do you solve it? This is called the zero product property. You take each factor, make it equal to, so if 1 is 0, 0 times anything is 0, or if the second factor is 0, then 0 times anything is 0. So first I'm going to take e to the negative 2x squared equals 0. And I'm going to solve that. How would you solve that equation? It's an exponential equation. You try to make the bases the same. Is that possible here? E to any exponent, would it ever equal 0? No, that's because this number on the left, no matter what number you plugged in for x on the left, would always be what? Positive. Let me say it again, right? If I plugged in a negative number for x, if I plugged in 0 for x, if I plugged in any positive number for x, the answer would always be positive. It could never be 0. So that means this one has no solution, right? Just no solution. It's not undefined. There's just no solution for x there. What's the other factor? Can you solve that? Solve it. And then tell me what two answers you get for x. What should you do first to solve for x? Add 1. What should you do next? Then do it. And then what do you do next to get x by itself? So I just told you to add 1, divide by 4, and then take the square root. Are you okay taking the square root of a quarter? Do you know how to take the square root of 1? Do you know how to take the square root of 4? Then you're okay with the square root of a quarter? So the answer is positive and negative what? 1/2. Now, how do I? Those are my critical numbers. Now what do I do? My goal is, where are the extrema, right? No. What do I need to do? I need to now test them to see what? If it changes from increasing to decreasing. So what are my critical numbers? Let's put them in order. Negative 1/2 and positive 1/2. Where do I test? Where do I test? The function or the derivative? Derivative. So where do I test? The function or the derivative to know if it's increasing or decreasing? So what's an obvious number less than negative 1/2 that I can plug in? Negative 1, negative 1 billion. So if you did that, what's going to happen? If you plugged in negative 1 billion, would that be a pretty large number? And negative times negative is positive. We could also use this one right here. Did I tell you that the first one's always what? Positive. So if I plug in negative, who cares, right? Negative a billion, that's going to become what? So a positive times a positive, what's this going to be? So when it's less than negative a half, the function is what? Increasing. That's what we found. What's the number between negative 1 and a half? So if I plug in 0, in front is always positive. 0, subtract 1. So between negative 1 and 1/2, what's happening to the function? It is decreasing. And then what happens when it's greater than 1/2? It's positive, because if you plug in positive 1 or 100 or a million, you can see that it's increasing when it's greater than 1/2. So do we have some relative extrema?
Yeah.
Good. What's negative a half? A relative max or a relative min?
Max.
Why? Good. How would I find the point?
Plug it in.
Which one would I plug in to find the y coordinate? So I have to plug it in up here?
Yeah.
Okay? Let me do that here with a different piece of paper. So if I plug in negative a half without a calculator, could you simplify this? So where there's an x, I plugged in negative a half. Could you simplify that? So first of all, negative times a negative is positive. What's negative a half squared? 1 over 4. And negative 2 times 1 over 4 is negative a half, or negative 2 over 4. That is irrational. It doesn't simplify further than that. So that's what I'm going to write down. 1/2 e to the negative 1/2. What happens if I plug in positive a half? What would that give me? Almost the same answer, right? The exponent would be the same. What would be different? Does that make sense that that wouldn't be the minimum? Because the y value is negative compared to being positive. So it's negative 1/2 e to the negative a half.
Well, isn't that positive?
What's that? Which one are we looking at?
The
Oh, this one right here, right? The x coordinate? Thank you. You're perfectly right. Yes. There is no way you can forget what we did in Unit 3 or 4 about derivatives, relative max or min, and the applications we did there. All right. Oh, wait a second. There's still more. Not just taking derivatives, but also what? Integrating. That's awesome. Remember I said, what's integrating e to the x? What is it? Plus c, right? Isn't that beautiful? And if we could maybe do the anti-chain rule, we will. We'll practice it. How about if it's just any old base, but not e? Remember the derivative you multiplied, right, by the ln? Now you're going to divide. Okay? That's the rule. And then don't forget the candy. All right, let's look at number 5. What's the base? 4. Oh, you know what's kind of sneaky? What's over here beside it? X. It's kind of sneaky, right? What's the derivative of x squared minus 1? So what I want for the anti-chain rule is 2x times 4 to the x squared minus 1. That's what I want. Why do I want that? Because the derivative of x squared minus 1 is what? But what do I have? So how do I make them equivalent? What does it need? Now it's set up. Now here's the good news. Once you have the hook there and you set it up, stop looking at it. Don't look at the 2x. Like once the hook is in place, you set it up, right? Now let's do the rule pretending the 2x isn't there because it's already embedded. So what's the rule to integrate with the base of 4? It's right above here. It's 4 to the what? Do you see this right here?
Yes.
The rule right above it. A is our 4. So what do we write down? 1/2 is in front, and we write down 4 to what exponent? X squared minus 1 divided by what? Beautiful. Now, in this case, we don't have candy because it's definite, right? So it goes from 0 to what? And then how would you finish that off? So I'm going to run out of room because I'm using a fancy marker. But I'm going to do this. And move this up. So what would the end answer look like then? The 1/2 is in front. What would I plug in first? And you don't need to simplify it more than this. So put in 1/2. Oh, let me write right so it's to the exponent. So the exponent is 1/2 squared minus 1 over ln 4 minus, now what number would I plug in? Over, and I'm sure you could make that look prettier if you wanted to, but that's it. If it was free response, you would let it go from there. It's okay to use a note paper and have an addendum. That's a fancy word. Addendum to this. All right, let's look at number 6. In fact, I'm going to write number 6 here and not run out of space myself. So, all right, other than giving up, what would you do next? You like that? I love that. Thank you, Candy. How would I write this more calculously so that I don't give up? Calculus doesn't love fractions, and it doesn't like radicals, right? I see fractions and I see another fraction. Get rid of it. How can I write that expression with no fractions? Go. Write what you see with no fraction lines. There's your goal. Can you do it?
Yeah.
I know you can.
Oh, I see what you did there.
Oh, I like hearing that. Anyone else have an, oh, I see that. Do you see that? You have a choice. You could have written it as 3x squared to the negative 1, right? That's the denominator without a fraction. But really, what number's there that you don't see? It's 1/3, right? And then x squared in the denominator can be written as x to the negative 2. E, how can you write 2 over x with no fraction lines? 2 times x to the negative 1. All right, let's do this. What is the derivative of 2x to the negative 1? X to the negative 2 is not an exponential because the variable is not in the exponent, right? It's negative 2 in the exponent. Start with the exponential. So what's the derivative of that right there? Negative 2x negative 2, correct? Negative 1 times 2 is negative 2. Subtract 1 and it's x to the negative 2, okay? Now this is the hook. What do I have? 1/3 x to the negative 2. All right, let's put the 1/3 in front so that it doesn't give us a headache. Write down what it needs to be. It needs to be negative 2x to the negative 2. I took the constant 1/3, put it in front to get it away from me. I don't want that to be my headache. How, if you take the 1/3 in front, how do I still make it equivalent? How do I undo the negative 2? What do I need in front? And that should be a negative. I've done nothing but algebra right now. So I took the derivative of the exponent, right? That's what's in front. But I need it to be equivalent to what was before, right? So what's 1/3 times negative a half times negative 2? It has to be 1/3, right? Notice the negative a half and negative 2 together make positive 1, and then what are you left with? They have to be equivalent. But now, we can just do our work. What's this together is what? Fraction in front? Negative 1/6. And then what's the rule? Remember to ignore the hook, right? We're good. So what's the rule? E to the, what's exponents here? And then don't forget the done. It's all in the setup. Once the setup is there, you follow the rule. And the hook is included. So the rule for E is, it's just E to whatever the exponent is, right? And we already took care of the hook. So you don't have to worry about it at the end. So the rule is E to whatever the exponent is. And we already took care of the hook. And is there a number in front, right, that we need to make sure we include? And it's indefinite, so we need the constant at the end. One more, number 7. All right, please look at it. What are we going to do before we do the calculus? Good. And so a basic rule is, if you see a fraction, write it without a fraction line. If you see a radical, write it without a radical sign, right? So I see a fraction. You have to rewrite what you see with no fraction line. Don't give up. Oh, this should be a -4. It's there. Look at the 2. Do you think that's complicated to change that from a fraction to an exponent? So what's in the denominator? You just make that exponent a negative exponent. That's it. And if it happened to be negative, you'd make it a positive exponent. But anyways. Nope, just the exponent. That exponent -4 means the reciprocal, means it would be in the denominator. These are equivalent. Now, we're not going to use the rules of exponentials to integrate here. Instead, I want you to notice this. That do you see e to the x plus e to the negative x? Just that part. What's the derivative of e to the x plus e to the negative x? It'd be e to the x plus e to the negative x, but what would it need? What I want you to see, and this is so tricky, right? Do you know that that is exactly what's in front? E to the negative x times -1 is the same as subtract e to the negative x. In other words, we have the hook, and we don't even need to change anything. It's already set up to integrate. What's in front is the hook. This is the u prime. This here is just the u. So in other words, integrate the u part and the hook's there. Well, how do I integrate? This is actually just the anti-power rule. So what's the base? E to the x plus e to the negative x. The anti-power rule is add 1 to -4, and it's now what? And then you divide by what exponent? And don't forget the done. I'm listening.
How did the -1 apply only to the right e?
So you're saying this -1 at the end?
Yeah.
Because the derivative of x is 1. So e to the x is just e to the x. But e to the negative x, the derivative of negative x is negative 1, which changes it to subtracting. And once it was there, it was just the anti-power rule, where we added 1 to the exponent and then divided by that exponent. And then the constant. All right, that's lesson 7-2.